Hi folks, welcome to part 2 of the motorcycle bracket. We need to make a fixture to op to this part. Remember last week we machined the top half, we drilled all the holes, cut the honeycomb, but now we've got to hold it from the inside so we can profile around it. Welcome to another Wednesday widget. So we're setting up a workpiece here on our Tormach fixture plate. Zeroed in with the Heimer, do a quick sanity check, and no good. Was out of Y travel, but that's one of the nice things about using a fixture plate is we push the vise back to the next set of rows, quickly trammed it back in, actually very quickly, and we're good to go again. It's funny, when you have the right tools, it's easier to make the right decision. In this case, we didn't have a choice because we were out of Y travel simply because of where the vise was located. The operations are pretty simple, some adaptives, followed by contours and horizontals. Let's dive in. First up is a 2D adaptive shear hog. 4,000 RPMs, about 785 surface feet, 13 thou per tooth, 55 inches a minute. .2 inch optimal load, and in this case full depth of cut, only leaving 5 thou radial and 5 thou axial. Our adaptive for the Mickey Mouse corner, our typical go-to 1/4 inch end to mill, max RPMs, 2 thou per tooth. .2D contours to clean it up, max RPM, backing the feed per tooth down to 1 thou just to give us a little bit of a better surface finish, a finishing feed rate. And then horizontal takes a little bit of time, but I want to ensure I have a really good floor finish because when we flip this over and set it down, we'll then deck it, which will establish that these two faces remain parallel. And then finally, a quick chamfer. And we made a goof. I should have realized this, but my stock, we've not trimmed it down to size in X. We'll do that when we flip it, so I should not have chamfered along both those edges. Here's the funny thing, the real kicker. I actually went back, fixed it on the left side, but still forgot about the right side, so we are all human. When we're done, I like using a foxtail. I'm trying to use less compressed air around the machine. Compressed air just tends to get chips into bad spots. Doing a knock test, setting this on here, feels solid. I like that. So we need to machine the top sides. Let me turn off the part visibility. Light bulb right here. Clicking that hides the part, but leaves my fixture active. We're adaptive it, horizontal for the floor, some contours to clean up, spot drill tap, and finally we're going to trace the logo on it. Shear hog's the best way to remove most of the material. We do have to leave a couple of posts here, and there's a debate of do you machine everything except the posts, or do you machine cavities and press in pins? In this case, we're going to machine the whole top down. It's only a 5-minute operation. Same recipe, 4,000 RPMs, actually a little bit slower, 40 inches per minute. Drilling with a 201, 3,600 RPMs, about 190 surface feet, and 3 thou per rev. That's a little bit light. We could probably go stronger. Pecking every 50 thou. And then to do the trace, I love this engraver from Lakeshore. It's been great. Max RPM, 2 thou per tooth, and it is a 2-flute tool. So you can actually move pretty quickly on it. The horizontal is really important here. We're only doing it with a 1/4 inch tool. Max RPM, 3 thou per tooth. That went fine going this quickly. You could step up to a larger tool. It would run more quickly. But I've seen a lot of folks that have done even really high-end mold work where they'll use the exact same tool, just because measuring 2 different tool heights is never going to be perfect. So yeah, it takes a little bit more time, but not always the end of the world. And we're done with our fixture. Tapping 1/4-20 with the flex arm. Nice thing is it fits right in the, in this case, the Wilton camlock vise to run our taps in and out. Only have to do that once, obviously. And then I didn't drill our workpiece on last week's Wednesday widget because I hadn't thought about doing the fixturing this way, so I did have to manually do those real quick so that we've got the holes lined up on the outside corners. This is going to hold the extra stock so we don't have to remove all of it, but rather can effectively do a type of slotting. Dial it in, again, back left, top of the fixture. Quick deburr tool, link in the video description. I love this no-go where you've got a little bit of an offset, makes it really easy to do round holes. And snug fit. Yes, it will absolutely, this will wear out over time, but you could remake it out of steel or you could remake it. And one of the things here is this part would get tumbled or blasted or finished. So yes, it's okay. It does not have to be perfect. Some washers to hold down and span across the webbing inside of it. If I had to do a lot of these, I would probably make an insert that spanned a larger portion, and then we could run it down quickly with the same 3 screw locations. This worked fine, but again, an insert that sort of matched the shape would be pretty nice. So the first time I tried to walk around it, 3/8 inch Taz. I wanted a little bit of a smaller diameter for less tool pressure, so smaller than 1/2 inch, but I also wanted the rigidity, so I picked a tool greater than 1/4 inch, 500 surface feet, which is max RPM, 3 thou per tooth. And over here in linking, the top rightmost tab, I picked a 3° or 0.375 max ramp angle, and what that does is the 0.375 causes it to go all the way down across one pass, and you'll see that was too much. And we're slotting, and yes, I hate slotting, but the point or thought was to use a roughing tool that has better chip evacuation, and this isn't our final geometry. And we do have good chip evacuation, it just ended up being too much of a cut. I slowed it down a little more and ended up settling with 0.19, which does it effectively in 2 passes around. I love the fog buster for this. It does a good job of blowing in there higher pressure air, and you can see and you can hear and see those chips being evacuated, and that to me is a good recipe. Would I walk away from the machine or the shop when this is running? Probably not. But take a look at last week's Fusion Friday, and you can see some tricks on how you can do micro-adaptive strategies to really avoid slotting whatsoever, but not add too much time. You know, it's a trade-off. A little bit more time, much better process reliability. And now we come in with tool 31. We're doing a cleanup, 2 thou per tooth. But the nice thing is here, yeah, we're inside of a slot, but we're not in any way slotting. We're only cutting on one wall, and plenty, other than me getting the line caught there on the left edge, plenty of room for the chips to evacuate. This is reliable, and our stock stayed in place, which is super nice. So I'm removing the extra stock here. What I would normally do is grab the second one on pallet B, throw it in the machine, tighten the vise, hit cycle start, and then I can deal with removing this one, inspecting it offline while the machine's running the next one. You could even have 2 vices set up. You could put these directly on a fixture plate like the one we've got here. And it's really a pretty good way to establish a little workflow. The great thing about these is that even if you need to make a change, you can put it back in the machine and it auto relocate very, very precisely. My advice would be make all the fixtures at one time if you can, and that's tough sometimes because you want to do R&D even on the fixture design. Who sees the mistake? We machined through our fixture engraving. Should have been deeper. Lesson learned. Hope you enjoyed, folks. Take care. See you next Wednesday.